Okay, so for this problem, we're going to be working on multiplying fractions. So our story problem goes, every holiday season, Tanya and her grandma love to decorate the mantle with popcorn garlands by stringing together pieces of popcorn and dusting them with gold glitter. After a bit of work, Tanya's grandma manages to finish 1 2/3 yards of strung popcorn. Then, Tanya dusts the gold glitter onto 3/4 of the garland her grandma had strung together. How many yards of popcorn garland have been both strung together by Grandma and dusted with glitter by Tanya? I know it's a little bit long. I was really trying to get creative though. Anyways, let's break this down according to our definition of multiplication, which, if you don't remember, our equation goes, so m times n equals p. So basically, m is going to be our number of groups, n is going to be our number of units in each group, and p is our product is going to be the number of units in the total number of units in all groups. So let's identify our values. So our n value is going to be, remember from our tip, our n value and our p value are most likely going to have similar describing words. And looking at this problem, let's start with our p value, which is going to be the easiest. How many yards of popcorn garland have been strung together by Grandma and dusted with glitter by Tanya? I just realized I switched tenses in this problem, but I'm not going to redo it. I'm just going to keep going. You still get it. So we're looking at how many yards. So that's our describing word. So to find our n value, one thing that might help is looking for our amount that has this same describing word. See, so 3/4 of the garland. So that's not the same, but 1 2/3 yards has the same describing word. So that's how we can tell 1 2/3 is going to be our n value, and leaving 3/4 as our m value, because we're finding 3/4 of this 1 2/3 yard of garland that Grandma has strung together. So let's write out our problem. So our equation is going to be 3/4 times 1 2/3 is equal to what? Another way of saying this is we're going to look at, we have 3/4 of a group. We have 3/4 groups of 1 2/3. And basically, when we're multiplying fractions, I discussed in a previous video, I'm not going to go over it a ton because I'm trying to make this shorter, but we discussed the relationship between multiplication and division as inverse operations. And basically, when we're multiplying fractions together, essentially, like a fraction itself is division. So taking, like, for example, 3/4, another way to write that is 3/4 is equivalent to 3 divided by 4. So when we are sorry, I lost my train of thought. But you know what? I'm gonna skim over that because we need to keep going. I have to keep going, Naomi. So our n value is 3/4. Our n value is 1 2/3, and we are trying to find how many yards of garland have been strung together and dusted with glitter. So it is entirely possible to solve this problem keeping 1 2/3 as a mixed number. But for the sake of explaining the significance of why we can multiply across, because if you basically when we have two fractions, a over b times c over d, we could solve this by just multiplying across a times c over b times d. And for the sake of explaining this concept, I'm going to change 1 2/3 into an improper fraction, just to help with this explanation and make it more simple. So that also leads me to a little task analysis of breaking down the steps of changing a mixed number into an improper fraction, which I think could be helpful for students, particularly students that benefit from routines and structure and explicit instruction. So just because this is a skill that they may need to use. So changing 1 2/3 to an improper fraction to make it easier to solve this problem, let's go through our steps. So the first step that we're going to do is, when looking at 1 2/3, is we're going to multiply our whole number and denominator. So our denominator, let's go over review terms. So our whole number is going to be 1. And basically what that means is that we have a group, since we're speaking in terms of thirds, 1 is going to be 3/3. So down here we have a pie divided in thirds, and we have all the pieces. I know that we like to stay away from pies, but I feel like it's easier to explain for this particular example. So thirds is going to, or our denominator 3 is going to be our number of divisions that we're dividing our whole into, our whole being 1. So we have 1 equivalent to 2/3, so 3/3 plus our additional 2/3. So we have another pie, but we do not have all 3/3. We only have 2/3. So one of them is missing. So our numerator 2 is the, I guess, amount of present parts, I guess. I could probably come up with a better explanation, but for the sake of time, I'm going to keep moving forward. So our first step, multiply whole number and denominator. So our whole number 1, we're going to multiply with our denominator 3. So 1 times 3 is going to equal 3. Our second step, we're going to add our numerator to the product that we just came up with in step 1. So we'll start off with our product 3 and adding in our numerator, which is 2. 3 plus 2 is going to equal 5. And then step 3, we're going to record our sum that we discovered in step 2 as our new numerator for our improper fraction, and we're going to keep our original denominator from for our improper fraction. So recording our sum as our numerator and keeping our original denominator, which is 3, we have formed our improper fraction. And the reason that we keep our denominator the same is because we are keeping our proportion of divisions the same throughout between our mixed number and our improper fraction. And another way to connect the significance of what we're doing here is 1 2/3 is equal to 5/3, because if you look at here, we drew our whole, which we know is the equivalent of 3/3. We drew 3/3 plus 2/3. So here we have our 2/3, and if we add together all of our portions that we have 1, 2, 3, 4, 5. So each of these sections is 1/3. We have 5 of them, so we have 5/3. So there's the connection between mixed numbers and improper fractions. Again, I'm sorry this was unnecessary, but I don't know. It was something that I did in the problem, so I figured I should probably explain that too. So I'm going to go ahead and erase this now. I hope we don't regret that. But now that we have changed our mixed number into an improper fraction, we have our new equation that we can work with to better explain this problem. We have 3/4 times 1 and 2/3 is equal to what? So let's draw a strip diagram to help us solve this problem. So let's start with Tanya's grandma as she finishes 1 2/3 yards of strung popcorn. I want to make it bigger. There we go. So a little uneven, but that's okay. So here we have 1 yard. So I told it, remember we're keeping, oh, I just realized I forgot to write 5/3. I'm sorry, I'm a little scatterbrained. Okay, so we have 1 2/3 yards, or 5/3. And remember when we were talking about changing our mixed number into an improper fraction, we're keeping our proportion of divisions the same, which is why our denominator stays the same. So when we're looking at our garland that we're dividing, we're going to want to divide this yard in 2/3. So 1 yard of garland. But the problem with this is if this is equal to, let's see, goodness, okay. This is equal to 1 yard. We don't have 1 yard, we have 1 2/3 yards. So we need to add, this is 1/3 of a yard, so we need to add 2 2/3. And I could also draw these solid. I just do it to remind myself that this is 1 and then this is starting into the next yard. So of this we have all of these. So this represents 1 yard of garland that Grandma has strung, and this represents 2/3 of Grandma's garland being strung. So 1 yard and 2/3 of a yard Grandma has strung. Now, of the garland that Grandma has strung, 3/4 of the garland has been dusted with gold glitter by Tanya. So dividing the portions we just shaded into fourths, we can determine how much of the strung garland has been shaded. So 3/4. So we're gonna shade this way 3 out of our 4 groups. So let's see. There's 1, 2, and 3. So let's see. Three-fourths groups. Right. 3/4 of strung popcorn glittered. And then this amount is going to be yards strung, or 5/3 yards strung. Okay. So, one way we could solve this is adding up all of these, all of the intersecting sections that are both shaded in blue and shaded in pink, representing the sections that have been both strung and dusted with glitter. Or another way we could solve this is just through an array. We could multiply 3 times 5, because we have 3 groups of 1, 2, 3, 4, 5, which will give us 15. So we have 15 out of, so we want to know how many yards of popcorn garland have been both strung together and dusted. So 15 sections, I guess, as of right now, have been strung and dusted with glitter. And out of yards, so we know that this section is 1 yard. So when we're determining our denominator, we want to, our denominator is going to be the total amount of sections within this portion, representing 1/3. And the reason we're not going to add in these sections is because we're not, that's going into an additional yard, we just want to look at the number of divisions made in 1 yard, which is going to be 12ths. So we have 15 12ths, which we can turn into a mixed number by, I won't write this one out, but task analysis, we can divide our numerator by our denominator. So how many times does 12 go into 15, which is 1. And then step 2, we can record our remainder as our numerator. So 12 goes into 15 one time, 12 times 1 equals 12. And then counting up from 12 to get to 15, we find we have a remainder of 3. And then step 3 is keeping our denominator, keeping our original denominator. So 3 12ths, which we can simplify down to 1 and 1/4. Now, another way of looking at this problem, rather than doing it this way, is, oh shoot, I forgot to, so I included this portion that helps add to my explanation, but I'm going to go back real quick. I'm sorry. Go back real quick and explain the other operation that we're doing through this picture. So this picture represents 3 groups of 5, and it also represents our whole. So okay, so 3 times 5, 3 groups of 5 represents the dusted and glittered portions. Now we also can do 4 times 3. And this number is going to be our whole. Well, no. Sorry. It's not our whole. Our whole is equal to 1 yard. That's our whole. But this number 12 is the number of divisions, I guess, that our 1 yard is separated into. Whole number of divisions. Yeah. Okay. So now that I've explained that, I can move on. So I mentioned that there's also a different way to look at this problem. Instead of solving it this way with our improper fraction and moving to 1 and 1/4 by reducing our fraction, we can also look at it as in terms of just how many yards have been both shaded blue and shaded pink. So just looking at our 1 yard, we see that we are 3 away from completing 1 full yard. So we can actually just borrow 3 of these sections and fill them over here. So just kind of marking those off and counting them over here. Now we're left with 1 completed yard, and our remaining filled sections can start our fraction of our next yard. So from this we have 1 completed yard, and remember these aren't here because we borrowed them and filled them in over here. We have 1, 2, 3 out of so 3, and we're not going to count this section because remember this is only noting 2/3 of a yard. we're gonna keep our number of divisions regarding our 1 yard, which we know that 1 yard is divided into 12 sections. So that's one way we could do it. And if you wanted to skip the simplification process, you could also look at it this way, and look at it as, let's see, sorry, just a second. How did I do that? You know what? I'm going to skip that explanation for now. Basically, you could look at the problem from this angle and note that you have 1/4 that's not filled out, I guess. So you have one completed section. Sorry, I just said I would skip it and then I started doing it. But one completed section, if you borrowed those, and then you're left with 1/4. You know what? Forget that. My brain's starting to turn off, so let's keep going. Forget that last example. So now for my explanation. Oh shoot, I wanted to keep that part. Oh well, that's okay. Explanation of why we can multiply across to solve this problem. So 3/4 times 5/3. We could also solve this problem by saying 3 times 5 over 4 times 3, giving us 15 over 12, or 1 3/12, which can be reduced down to 1 1/4. So from our picture, we discovered that basically this operation right here is describing the portion that has been dusted and that has been both dusted and glittered. So three groups of 5, essentially giving us 15 portions that have been both dusted and glittered. And our 4 times 3 describes our whole, which I erased, but we did down here. Oh no, it doesn't describe our whole, I'm sorry. Our whole is 1 yard. It describes the number of divisions that our whole is divided into. And the number of divisions being 12. So that's kind of how our strip diagram can visualize why it is that we're able to multiply straight across when multiplying fractions. Okay, that was a really long explanation. Let's go ahead and move on to my last video, which will be multiplying decimals. Okay, I'll see you then.